Course 1. Lesson 5. Game and Inspector Window. In this lesson, we will focus on the Game and Inspector windows. Game is a final preview of what your game is going to be. Inspector, however, is more important, since in it you will customize the objects you have in the scene. Come with me and we look at it together. The Game window is the preview of our game, where you can test it and you can pause it and execute frames. Above you will see the controls that allow you to customize how the game is shown through the window. The first menu is the screen selector. The options are linked to the cameras that we will have in a scene, although he almost always works with only one. If you want a camera to be associated with the displays in this section, you can do it with target display inside the camera component. The next menu is the aspect ratio selector, or aspect ratio, which allows simulating screens with resolution settings. This way we can see how the game behaves in different monitors or resolutions. This is useful when you work or design the interactive menus of the game, besides allowing to see the field of vision that a player will have from the stage, depending on the monitor where it is played. Keep in mind that out there, every screen is a world. Each resolution is a world, and it is good to know and test all this before launching a video game. You can add your own options if you press the More button, name the customization, and add the corresponding values. What do you want to test? To the right of the menu, you will find the slider for the scale, or zoom, which runs in the window, and that will allow us to see in more detail portions of the game window if we wish. Although keep in mind that the zoom is not an exact representation what the player will see, so be careful and use it only to test certain details. The following allows to activate or deactivate the option to run the game in maximized mode by pressing the play button. Don't worry about the aspect ratio or the selected resolution, since Unity will do everything possible to respect it. It's a very useful button, although it can be annoying. Well, if you want to change execution options, you will have to minimize the screen. Mute audio button allows you to mute the scene and turn off all sounds while the game is running. The next stats button is very useful, as it will show you game and scene execution information, helping to improve game performance. Even so, because we will make a small game for now, we will not give much use. But it is good to know that this indispensable tool will be very useful when optimizing future games. Finally, the Gizmos button behaves like the Scene button, allowing to activate or deactivate visual guides in the game camera while running. Although keep in mind that these gizmos, activated or not, will not be seen in the final version when running outside Unity. They are a visual aid in development. Keep in mind that when you run a game, the changes you make will not be saved. It's important to know when you're in that mode. Well, you can ignore it. Unity allows you to select the color of the menus when you run the game. To do this, go to Unity, Preferences, Colors, and select a color for the Play Mode Tint option. You will see that in this way you will know the execution mode in process, and you'll know when to save the changes you've made or not. As we said in a previous video, Inspector is context sensitive, and that will allow modifying object and asset properties, and even of project configurations of the same Unity. Depending on the selected object, the window will show other options. If you select an object from the stage, you will see very different properties to if you select a specific type of asset, like a sprite or an animation clip. The object you will work with the most are the game objects, which are the ones you will use and move on the scene, although you will find them in the project when you save them as prefabs. Don't worry, because we will see the prefab concept later. But for now, you can think of them as blueprints, or blueprints from which you will create equal objects more easily. When you select an object, you will see that the first section shows information about the name as its name, which you can change. You can also modify its icon to make it easier for you to recognize it in the scene or in the hierarchy window, and even deactivate the object so that it has no interaction in the scene without deleting it. A disabled object is there, but it doesn't execute any script, nor will any object interact with it until activated. You can see that the deactivated objects appear semi-transparent in the hierarchy window. The static selector allows us to indicate to Unity if an object will be static inside the scene. That is, it will never move. It will allow you to optimize performance, since static objects, will not be taken into account when performing the necessary mathematical calculations for physics. We will see this also in future lessons. The tag and layer fields will be seen later, but you can go thinking about them as follows. Tags are used to identify types of users. Imagine player, enemy, power-up, bomb, bullet, and so on. It will allow us to identify the belongings at a certain type. Layers, however, will allow us to group objects into logical communities and are mainly used in physical control or rendering. Think of layers like lighting, or layers for walls, or layers for the user interface. You can add your own tags and layers. Later, you can give them their own name, and you will use them a lot in the course. Then the first component that objects have will come, as we said, transform, which indicates the position and properties of the object of the scene. You can change their values with the transformation tools, or with these fields directly. Another more important function of the inspector window is to show the components and properties of said component of the same object. These properties can be numerical values, activatable values, menu values and selection, or reference values. When writing a new numerical value, keep in mind that you can write it in the field, or click on the name of the value, and drag the mouse from left to right to change its value. You should also know that the fields accept mathematical functions, as addition, subtraction, multiplication, division, etc. When a value in the reference is of the reference type, it indicates that we can include other objects within this property. To the right of this field, you will see a small icon which opens an object selection window if you click it. You see that this property is very useful for maintaining relationships between objects without searching for them by code, and we will see them in detail in the programming section. Keep in mind that you can keep an object activated in the scene, but disable its component. You will use this sometimes, since you will want the object to do or stop doing certain functions, but follow the scene without disappearing. Think of a dead enemy object that was left lying on the stage, but you don't want it to keep moving, so you would deactivate its artificial intelligence component. It is useful to know that objects are modified at once if you select several by pressing Command+click on Mac or Control+click on Windows, although keep in mind that only the components will be shown that these objects share, among themselves, the transform component. It is useful when you want objects of the same type share the same properties, and you would not go one by adding them. Finally, it is the most important. When you change properties of a component in execution mode, these will not be saved when I finish that mode. So be careful, since many times we will have to refine properties like the speed or life of the characters while running the game. And when leaving this mode, we will lose the settings we have entered. The trick to keep it is to right-click on the component and copy the component, so that at the end of the execution mode, you go to that same component, right-click on it, and select Paste Component Values. Remember to save the scene every time you make changes, since Unity can close by chance or your computer shut down. The shortcut to save a scene on Mac is Command+S of Save in English. In Windows, it will be Control. You saw that it is not so complicated. Stay with what Inspector taught, because with him you will work hard. In the next lesson we will focus on the architecture of a project.